And here we go. I'm gonna take this slide right here. I'm gonna come back to that when we return from the break, and I'm gonna go a bit more into detail into this. But I think right now, if I just do a couple of examples, that'll be more beneficial. But type 3, and you're wondering, what about type 2, Mr. Dirksen? Wasn't there a type 2 somewhere? I'm gonna wait with that till after the break. This one is more important to me. So type 3 is what I call maybe a story or a scenario. And this is the important part on page 71, okay? You're provided with 2 points. You have to find the third point using symmetry. That is the very, very important part of this type of regression, okay? So we use the symmetry of the parabola to do this. I'm going to use a different color. The best way to solve this is to sketch it first, and then the third point is across the starting point. Usually the third point will be across the starting point. And this is what I mean by that. Maybe I'll just use this partially, the diagrams. If something starts on the ground, if you start here, you are guaranteed, if you travel along the same height as where you started, that's what I would call the third point. So this is the third point. What's this one here called? The vertex. That's point number 2, right? So you start here, vertex, but the third point, arrowhead going right across because of the symmetry, okay? Or else, look at this one here. Something starts it's not on the ground, it's off the ground. So if you start right here, let's make an arrow, right? This is your starting point. Make a big dot there. Where is the third point located here? The one that I'm going to use for my regression. Some students are like, arrow down to here because it's always the x-intercept. You want to resist that temptation. You want to say, well, I know that there's one right across. I know that there's one right here. This is what I call the third point. So there's a start, there's the vertex, and there's the third point. Okay, that's what I want you to remember. That's like the cycle we're gonna use to solve these types of problems. Okay, so I'm gonna come back to this slide after the break. For now, I'm gonna jump right in. So we're gonna go to page 72 here. Let's dive in here. Roger would like to recycle his beverage container. He throws his container up from a height of 1.75 meters and estimates that it reaches a maximum height of 2.8 meters after 0.75 seconds. The container lands on the rim of the recycling bin. Okay, on the rim. Okay, lands on the rim. That should kind of catch your eye there. Doesn't hit the ground, lands on the rim. The bin is 0.65 meters tall. I'm going to highlight some of these things, right? Like this is important. That goes together from a height of 1.75 meters, and it lands right here, 0.65 meters tall. Now, when you do one of these, please do a sketch, okay? Don't just be, I know some of you are pretty good at just doing it all in your heads, but I would say this. If I pictured this doesn't have to be a pretty graph. I don't care about the scale, nothing. This is just a sketch. Just a sketch. Can we imagine what's happening here? It's somebody is throwing it at a height of 1.75 meters. So this is height and this is time. That's usually how it goes. You want time along the x-axis, height here. So the beverage container is thrown from here, reaches a maximum height, okay, somewhere over here, and then drops. Where does it drop? Where does it land? It lands on the rim of the garbage recycling bin. Right? It lands on the rim. I don't know if you picture those rims, right? Like it's just a small hole, but there's like a flat surface. It can land on there. So there we go. What's the first point here? The very first point is given by, right, it's thrown from a height of 1.75. That is when time is 0, the height is 1.75. That's point number 1, because you always need 3 with quadratics. What about this one over here? Do I know what this is? I actually do. It reaches 2.8 meters after 75 seconds. It says maximum, right? This tells you that this is the vertex. If it says minimum or maximum, you know this is the vertex. Okay, so this is 0.75. Don't mix this up. Okay, some students mix up time and height here. Okay, so that's point number 2. What's my third point? And I don't know, some of you would say this one is my third point, Mr. Dirksen, this one right here. And I would say resist that temptation. I'm going to use my pink highlighter again. Let's focus on the one that's across where you started. This is the third point right here. We're going to focus on that one. Make it nice and big, the coordinate here, because we're going to do some. If this is 1.75, you're staying at the same height, correct? Then this will also be 1.75. That doesn't change because they're right across each other at the same height. What about this one here? I'm going to use a red pen for that. This is the 1 mark associated with this question. Okay. If it takes, let's make an axis of symmetry here. If it takes from 0 to 0.75 to get halfway, it'll take another 0.75 to make it to this point here, right? That's the axis of symmetry, right? So this x value tells you how far you went this way. It's going to be another 0.75 to get that way. So what I do is I just tell students, hey, take that number and just multiply it by 2. You get the 1.50 or 1.5 in there. Okay. This is the third point. Okay, third point. This one right here. The other 2 were given. This is the third point you've created. You've come up with using the symmetry of the parabola. And you might wonder, what about the 0.65? Like, what's up with that? Right now, it doesn't mean anything. Like, not in terms of figuring out the equation for this parabola, because we have our 3 points. We might use this later on. So, determine the quadratic equation. What I want you to do is I want you to go T and H and put the points on here. Okay, so you copy down your points. It's 0, 1.75, right? And then it's 0.75, 2.8, and then I come back to 1.75, and this one is 1.5. Okay. Maybe I'll do this. The whole purpose of this diagram is to be able to come up with your points. This goes into L1. This goes into L2. So we're going to go stat calc, quadratic regression. I'm going to already start with y equals because a lot of you omit that part. Make sure you write down y equals. And let's enter this into our calculators. Stat, edit, clear, 0, 1.75. No, not 1.75, 0.75. 1.5. 1.75, 2.8, 1.75. What now? Well, for me, I use this with my other classes, right? So I got to check, is plot 1 on? Yes, it is. I happen to be here. I'm going to clear everything that I see. But now I'm going to perform my regressions. Second 1, comma, second 2, comma, alpha, trace. And there's my equation. So you write that down, rounding to 2 decimals. So it's negative 1.87 x squared plus 2.8x plus 1.75. So you expected the 1.75 at the end, right? And now this turns into just a normal word problem, just like we've done before, right? Once you've got your equation, you can answer anything I throw at you. So this kind of goes way back to starting word problems. So let's answer this. Maybe it's good to see if we can see this graph on our calculator. So I'm going to go zoom stat, because when you do this, you can use that zoom function. It does a pretty good job. However, it doesn't solve everything. So you got to go window, change your x-min to negative. It is already negative, so I can just leave it like that. And my y-min, also change it to a negative number. Maybe -1 will do in this case, because your y max isn't that big, so don't go too far down or else it'll be focusing too much on the other quadrants. Let's see if that works. I'm going to hit graph. Pretty good graph. I want to increase my x max, so I'm going to go window, x max. I don't know, I'm going to go 3. That's a pretty good graph right there. It shows the first quadrant. That's what you want. Okay. So I will say this: plot 1 on zoom stat, and then adjust window. Maybe write this down, because especially when it's time for exam review, some of you will have forgotten these things, right? So plot 1 has to be turned on, and you can use zoom stat and adjust your window. X-min, Y-min should be negative. Not by much, but I would put a negative in there. All right, let's, what does it ask for? How long does it take for the beverage container to reach the rim of the recycling bin? When does that happen? Like, what kind of information do I have? Right? Hits the bin. Sorry. Hits the bin at a height of 0.65. So you have to be, you're solving problems, right? Hits the bin at a height of 0.65. So that means we don't know what the time is, but we know that the y value at that particular point we're interested in is 0.65. So what would you do if you have the y value? If they give you the y value, guess what? We're going to go y2 is equal to 0.65, and then we're going to find that intersection. second trace intersect. So y2, 0.65. That graph, there it is. So it's on its way down, right? Sometimes the line that you graph may say it may hit it on its way up. You would want to make sure it hits it on its way down. You don't have to worry about that in this case, but that's the point we're interested in. So second trace intersect, just go closer than the other one, and just hit enter, 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 and I get 1.82. Okay, x is 1.82 seconds. If you put units next to it, you're good to go. I don't require a whole long sentence, but it depends on your teacher, right? That is your final answer. Never hits the ground. You see that, right? This never hits the ground. Just keep that in mind. Sometimes things do. This one doesn't. How long does the container remain below 2.5 meters? Below. You should think delta T. If I were like, if I read this, like, oh, okay, like how long below? Okay, so I'm gonna do a quick. It's like that. That's the path. And 2.5, where would that be? This is 2.8 way up here. So 2.5, graph it first if you're not sure. We're going to let y2 equal to 2.5. I know it looks like chicken scratch, sorry. I'm going to go 2.5, clear it, 2.5 for y2. So I'm interested, watch what the question says, not the time above. I care about the time below that. Right? How would you do that? Can you find those two intersections to 4 decimals? See what you get. I'll do it here as well, but 4 decimals when you're planning on subtracting. That's what I got. 1.1509 rounded and 0.3491. So delta T is subtracting them. I'm getting 0.8018 seconds. What did I find when I did this? What happens between these two times? Let's look at it. I'm gonna go, if this is the line, 2.5, then this is time 1, and this is time 2. What happened between those two times? Where was this can? Above, wasn't it? So this is above. So what is the trick to find time below? total flying time, right? Total flying time minus time spent above. So tricky. When we do examples as teachers, I try to make it like the hardest possible so that if I ask you anything in between, then you should know what I expect. So time below, I will just call this T below, okay? Will be total minus time above. Oof, that's small. Time below is total minus time. So total is, when it lands, it's all the time that elapsed until it hit the rim, which would be already determined 1.82, right? So this is 1.82 minus 0.8018. And that is 1.02 seconds spent below. Hello. Page 72. I like to highlight things, so I'll just maybe say that right this time right here is that stretch. And this time right here is basically everything else. Before I graph this, like now we're talking nice graph, scales, all of that matters. I want you to come up with a domain and range. Quite often, 2 marks, right? So what would be the domain and range based on this? For my domain, we start at time 0, right? It's my x values. And we stop when it hits the rim, okay? I would say this. Hits rim at 1.82 seconds. Okay, so that's when the storyline ends. For my range, some of you went 1.75, which I get it. It's like the starting, right? My starting height is 1.75, but it does get lower than that, right? It gets to the rim. So for the range, this should be 0.65 all the way up to 2.8. So a lot of you did have the 2.8 there. Okay, so this is hits the rim at 0.65 meters, right? And this is the vertex highest altitude. Okay, now let's graph this. Okay, you have to be good at that too. So this would be time in seconds. This would be height. We have what? Meters in this case. So it's meters. So we have that. And that's where the domain and range helps you, right? 0 to 1.82, that's all you need for your x here. So I'm going to go half, 1, right? 1.5, 2, and so forth. And for my altitude, I need to go as high as 2.8. So I'll do the same actually. This is 0.51, 1.52, 2.53. Okay, so there's a 3 up there. Equally spaced out, we're good to go. Let's plot the points. 1.75 we start. This is 1, 1.5, 1.75 is right in between 1.5 and 2. Make a dot. Our vertex happens at 0.75. That's exactly here. Let's go up and we go all the way to 2.8. This is 2, this is 2.5, 275, 2.8 is just above that. And then at 1.8, this is 175 here, this is 1.8, is right about there. We go to 0.65, this is 0.5, 75, 65 is right about there. And then just connect the dots. Oh, Mr. Jerkson, then we find one. Remember the third point, 1.5, 1.75? Absolutely, if you want that one in there. You have 4 dots now. You can make it even nicer. Okay, so that's what I would expect you to do here. And the equation is this. There you go. That's a full marks for that graph there. Just make sure you don't go past your domain and range. Yeah. This one here? Yeah. This is the rim of the garbage bin. So this one is 1.82, 0.65 essentially. Does that make sense? This is the rim. Okay, right there. So this would not be hitting the ground. Yeah. Yes. It's not 2.8. Good catch. All right, I have to fix it. Sorry, guys. I hope you caught it and you just let me do it, right? That's kind of it's always fun to let the teacher mess up, right? It's like, haha. There you go. Let's do it again. Yes, this is 2.5. So 2.8, this is 2.75 here. 2.8 would be right about there. Let's do it again. There you go. That looks better. Thank you. Everything else all right? So again, I don't need all points, but in this case, why not 4 if we have the coordinates, right? Why not 4? Okay. I want you to practice. So we're going to go to 73 here. This is what I want to do for now. We're not going to answer anything past A, right? So I want you to, or basically find the equation. So I want you to find the equation for the question on page 73. Sketch, come up with your points. I want you to then stop and then go to page 74. Fill in the chart with the points. You might want to make a sketch, but also determine the equation. Okay, you stop there because then I'm going to come back and check and make sure you're on the right track before you answer the rest. Because I do want you to answer the rest, but right now, can you come up with the 3 points? Okay, so 73 and 74, give that a go. Imagine the scenario, sketch it, put some points down, and find the third one. So I want to focus just on making our equations. That's what I'm focusing on right now. If you go to page 75, what type is this one? Don't worry about the type, but would you know what to do here? Do you need to make any points on page 75? You don't need to make any points. You just type this into L1, L2, boom, you go, right? So just be aware of that. So I threw that one in there. Page 76. So I want everybody to go to 76. Um, let's come up with that one. This one is a little same strategy, just there's something different about this one. I want you to figure that one out. So go to 76. What's a QR code there? Is that me? Is that the answer key? I'm just gonna try it. I don't even know. What's a YouTube video? Must have, yeah. Okay. That's a YouTube video, me solving it, but maybe do it without watching it. Just try to come up with the equation of this one on page 76. All right. And then I'll go back over the other ones you've just done. I just want to make sure you know how to come up with equations given a story. Okay. So give that one a try. See what you come up with. Okay. 76. Give it a try. Sorry, guys. Good job, guys. You'll only learn by trying. And if you make a mistake, who cares? You might be as lucky as me. You know, I don't make mistakes, but unfortunately for you, you will make some mistakes. I'm just kidding. All right. It feels weird. First time I wear a mask in I don't know how long. But I'm fighting something. I don't want to give it to you. All right. Let's start in 76 and move backwards, all right? Oh, I was recording this whole time. Okay, anyways. So in this case, Steven and a friend are throwing a paper airplane at each other. They stand 10 meters apart and catch the airplane 1.2 meters above the ground. Okay, so they're both catching them at that height. Steven throws the plane on a parabolic flight path and achieves a minimum height of 0.3 halfway between him and his friend. That is a key there. That's the vertex right there. Okay, so you got to imagine it's not always time and height. In this case, it's distance and height. Okay, so you throw it, one friend throws it to the other, it reaches a minimum, and then it's caught again. What do we know? That at a zero distance from the person throwing, it's at a height of 1.2. Okay? We're told it's thrown down because we know that this is a minimum. So this is 0.3. And we don't really know what the x value is just yet. But we know it's at a height of 0.3 there. We are told that 10 meters, like this is 10 meters long, right? That they're standing apart from each other. So it's safe to assume that this is 10 back to 1.2. They're both at the same height. So in this case, these 2 points are given. This one, I don't know yet. So what I'm going to do is I'm going to take the 10, and instead of multiplying it, I'm going to divide by 2. I'm going to half it. So this is 5, 0.3. So at a distance of 5 meters, it gets to the low point of 0.3. Does that make sense? Some of you tried it. So also guys, make sure this is first, this is second. So we're going to go distance, height. If you mix that up, it's not going to give you the right equation, or it's going to complain straight up, right? So 0, 1.2, 5, 0.3, 10, 1.2. You should see, that two are the same heights, so these points are across from each other, you should see that the vertex, right, is doubled to get to that third point, or half, right? You go backwards, it's half. So you should see that pattern. We go stat, calc, quad reg. I'm actually gonna graph this, do the whole shebang with this one. So let's go and enter that. If you haven't done so, do it right now. Follow my lead. 1.2, 0.3, 1.2. There we go, stat calc. Oh, I did a regression, so I'm just gonna copy paste. Bingo. I'm gonna hit graph. This one is pointing up, so I'm expecting a positive A value, correct? So let's graph it. Terrible screen window for me. It's not working. So you can go zoom stat. You can do whatever you want, okay? I'm gonna go window. And I know things already. The X max, right, is 10. So I'm going to go 12. My Y max, you go as low as 0.3, as high as 1.2. So if your max is 1.5, that will be just fine. And there you go. That's your graph. Okay. So let's copy that equation down. That's 0.036. It doesn't hurt. Plus, oh, it's minus 0.36x plus 1.2. So that's what I would be looking for. Oops. This one is worth 2 marks. So to be honest, on a test, I would give you a mark for finding that third point and a mark for coming up with the equation. So if you get the point wrong, but you still do the equation, you get 1 out of 2. Right? All right, so what is it asking next? Determine the height of the plane when the plane is 2 meters from the friend. Say what? 2 meters from the friend. So what X value am I looking for? If you want, okay, it would be right here. At 8 meters, I'm wondering what the Y value is. Because there's a 2 meter difference, right, between, there's 2 meters from the friend. So we go 10 minus 2 to get that 8. Okay. So we're going to go second, trace, value, X. You're constantly asking yourself, what do I have? What do I need to find? Right? Do I have X or do I have Y? And so Y is equal to, second trace, 1. That's 0.62 meters. Coincidentally, if you went second trace 1, X is equal to 2, I think you get the same answer. That's just luck, right? So that's what you're supposed to put there. State the restrictions on the domain and the range of the function in A. What is this? Well, I want you to be prepared for that, because in grade 12, sometimes we talk about the domain and range as the restrictions that you put on your function. You're saying it's only valid from here to here. Okay, guys? So for your domain and range, we're going to figure that out. Okay? So for your domain is what? From distance of 0 all the way to when it's caught, which is 10. The range, what's the lowest it ever gets to? It never hits the ground, right? 0.3. And the highest is 1.2, sorry. 1.2. So, right, again, it's from 0 to 10, that's my domain, and from 0.3 to 1.2, that's my range. So you can think of it that way if you want, okay, if that helps you. Some of you are still doing set notations. I'll do it here, squiggly brackets, 0. You can use X and Y here if you want, because they don't give you any other variables. Oops, 0.3, sorry. Right, if you want it that way, that's fine. Determine the distance the plane stays at or below 1 meter. State the distance. So you're gonna wonder what delta D is, not delta T. Its distance is the X value in this case. So we're gonna go D2 minus D1. Okay, so we're gonna go and find distance 1. We're gonna find distance 2. We're gonna let Y2 equal to 1 meter. And then we're gonna go second trace, intersect. Okay, so here we go. Y2 is equal to 1. Hit graph. There it is. So let's go find both of those intersections. 4 decimals, right? You can't just say, like sometimes I've had students just give me that. Like distance 1, it's 0.59. Well, that's when it starts, right? That's when it starts, but it continues. So second trace 5. Oh, I'm gonna jump lines to red line. That's what you do when you're in a cafeteria lineup, right? You just cut, right? Don't do that. 9.4096. Okay? Okay, question. If I subtract these, is that my answer? Let's read again. Determine the plane where the plane stays at or below 1 meter. When you subtract these two, I need another pencil. Okay. You're actually, when you subtract these, you're actually finding out what happens between them. And what happens between the 2 points you just found is the plane being below, at or below. Okay? Yeah. Right. Well, it's, I want to be careful here. It's, ask yourself, when you find this point and that point and you subtract them, ask yourself what happens in between those 2 points, and it happens to be below it. If it had been above it, yes, then it would be, how long was it above it? Yes, it does have to do with the minimum. So watch out for that. But always look at the graph, what happens between those 2 points. Okay, so delta D. Where's my key here? Just to speed things up a bit. It's 8.82 meters. There we go. Graph this scenario. Let's do this quick, because you can bet that you're gonna have probably 2 graphs that you're gonna have to do on the quiz. Okay, so we go distance in meters, height in meters, and I'm quite particular with all those steps. Okay, like label and units, right? And now my scale, what works? 10 apart, right? So let's see here, 2, 4, 6, 8, 10. It works perfectly. Couldn't be better, okay? Height, I go all the way to 1.2. So I'm going to pick something that works. Let's see here, 0.2, 0.4, 0.6, 0.8, 1.2. That's just beautiful, right? You're probably disagreeing. There's nothing beautiful about, oh, wait. 2, 4, 6, 8, 1. Oh, not a good one. Watch what I'm going to do. I'm going to go up by 0.3. So 0.3, 0.6, 0.9, and this is 1.2. That works. So you have to make adjustments. You have to be like making adjustments on the fly sometimes. So 1.2 and then 10 across right there. And then it's 5, 0.3. It's actually perfect. Right? So we go up, and then we go up, and we go 0.036 minus 0.36x plus 1.2. This has everything you need to get full marks. So I'm going to say, and I'm going to post a key, homework is going to be finish 73 all the way to 76. I'm going to go 76 because the key is going to include this. But obviously, if it's already done, why would you do it again? So for the quiz, right, make sure you know type 0, type 1, which is the profit, and type 3. I'm going to be heavy on that. Plus just word problems in general. Like if you're just given a word problem with the equation, just type it in and answer, okay? Sometimes students only focus on what I write down. I would say everything we've done so far. So, but in particular, review the quadratic formula. Make sure that's on your study sheet. And just graphing. So if you go back to any of the homework I've assigned, there's tons of everything, okay? And if you go to Google Classroom, everything is by topic, by date. So if you say, hey, quadratic formula, that was like, what, 3 years ago? That was last week. So you just click on that and just review for the quiz tomorrow, okay? There we go, guys.